Hi, my name is Omri Haviv and my partner is Lior. We study at the College of Management Academic Studies. Our lecturer is Lior and we are glad to present to you our final Java project. The main goal was to build a 3D maze by using the knowledge we claimed during the course. At the beginning, we learned how object-oriented programming works in Java. We learned about inheritance, abstract classes, and object classes. Afterwards, we learned several algorithms like BFS, Best First Search, and DFS, Depth First Search. The DFS first builds the maze walls between the entrance and the exit. The algorithm makes sure that there is a solution for the maze. There are many possible solutions to solve the maze. The player can choose between three possible solving algorithms: BFS, BFS, and DFS. Each one of them works slightly different to achieve the goal of finding the maze exit. The BFS algorithm calculates the shortest path towards the exit. It is done by using a priority queue and a set of nodes. The algorithm makes sure to apply on each node. Each iteration we remove one node from the priority queue to the node set and check if this is the goal node. If not, the algorithm checks all the next steps available from this position. Another algorithm we used called DFS. This algorithm starts searching for the exit until it's impossible to move. Then it marks the impossible way nodes so it won't repeat them. Then goes back to the last position he can continue its search from. In our project, the algorithms are object-oriented based, which means that the problem and the algorithm are separated. This pattern, called strategy pattern, taking different maze problems and inject them to different solve algorithms. Another pattern we used called decorator pattern. It allows behavior to be added to an individual object, either statically or dynamically, without affecting the behavior of other objects from the same class. For instance, applying our own compression code addition to the right file. One more pattern called object adapter. The adapter contains an instance of the class it wraps. In this situation, the adapter makes calls to the instance of the wrapped object. MVC design divides a given software application into three connected parts, so as to separate internal representation of information from the ways that that information is presented to or accepted from the user. MVP design is a form that the Model View Controller MVC architectural pattern, and is used mostly for building user interfaces. In MVP, the presenter assumes the functionality of a middleman. In MVP, all presentation logic is pushed to the presenter. In our project, we used observable interface to implement MVP. Let's continue to the GUI presentation.
Oh great, you are finally here. My name is Lior. Let me take you to the next phase of our journey, the code part. Let's see how things work. We will start with the command line interface. As you can see, we can hit a question mark key for list all of the available commands. Some of the commands here are used by both command line interface and graphic user interface. Suppose we don't know what is the correct syntax for each command, we can try type the command itself without any parameters. The output will guide us accordingly. In order to switch to graphic user interface, we need to run set settings command. All of these settings are located on XML file under the project root directory for a caching purpose. Each setting we will change now will be saved and used next time we run the program. Now, let's type exit and switch to graphic user interface. This is the main window. The main menu contains some buttons, which some of them are grayed out now. Clicking on New Game button will activate the rest of the buttons. Let's make a new game and provide some parameters. This is the main game board. We can use the arrow keys to move the red ball inside the maze. If we got a double-sided arrow on the red ball, it means we can go to higher or lower floor. When we arrive to final floor where the goal position located, we will see exit icon. If you lost your way home, you can ask for a hint, which will move the ball one more step towards the maze exit. If you're a quitter, you can give up and let the engine do the dirty work. Walk you through the solution path. If you have a vision problem, you can click Ctrl and scroll up and down the mouse wheel, which magnifies the maze window. I would like to save my maze to local hard drive to continue playing later on this exact maze. Let's change the program settings. We can decide with which algorithm the maze will be generated, simple or advanced. Also, with which algorithm the maze will be solved. Now, let's save the settings and go back to CLI. Remember the maze we just saved? Let's display it. Searching for this. This is the maze we just played on the GUI interface. You can notice that both CLI and GUI are fully synced. That's it for now. Thank you, and we will meet in the next project.